The second approach we can use to make a conclusion about a null and alternative hypothesis is called the p-value approach. So a p-value, and it's important to determine what that is first, the p-value is the probability of calculating a test statistic as least as extreme as the observed measure, assuming the null is true. A lot of things going on there. So let me just give you a basic example, and it's not going to involve any calculations. So if I said I'm not feeling well, and we'll just say I come into class, I say I am sick, please leave me alone, I'm just going to get into class, get done and leave, please, I'm not feeling well. But then, so you as good students will just take that to be true. All right, you're going to assume that that hypothesis, that is just equal to being sick, it is true. Then I start doing backflips and cartwheels and moving around the classroom with high agility. You need to think to yourself, okay, if what he said is true, what's the probability that he's doing all these things, that he's doing backflips and cartwheels and he's running around the room? Probably pretty low. If what he's saying is true and I'm observing what I'm observing, the probability of me observing that, given assuming that he's actually sick, is very, very low. So what we just did there was we assumed something to be true, we calculated the probability of something happening, in this case me doing backflips and so forth, assuming that I was sick, and found that that's just too unlikely to happen. So we would say, you know what, he's lying. There's not evidence to support his claim that he is sick. Pretty stupid example, I know, but it kind of helps us to understand this. Remember, with our null and alternative hypothesis, we are assuming something to be true, then we are making an observation, we are taking a sample, and then the p-value is the probability that we actually get a sample like that, assuming that the population parameter is equal to some amount. We're assuming the null is true. What's the probability that we actually get the sample that we did? So in this particular case, we're always going to be comparing our p-value, the probability of getting a particular test statistic or observation. If the p-value is larger than the level of significance. So let's say we have our level of significance, we could do 0.05, we could do 0.01, or we could do 0.10. Those are the three most important ones. So if we assumed that, let's say our level of significance was 0.05, and I calculated the probability of something occurring to be approximately 0.12. In this case, the probability, 0.12, is larger than our level of significance. If this is true, we would fail to reject the null. In other words, we can't say for certain that this is significant. Fail to reject the null hypothesis. There's not enough evidence. It would be really strange if the probability was less than 0.05, and that's obviously a measure that we decided on. But since it's not less than 0.05, then I can't say for certain that it's not happening by chance. So if the p-value is less than the level of significance, so if our p-value is less than our alpha, then what we're going to do is reject the null. So if I say my level of significance in this example is equal to 0.01, anything that has a probability of 0.01, less than 0.01, or a 1% chance of occurring, I'm going to call that significant. So if I calculated a p-value that was 0.005, in other words, this is the same thing as 0.5%. Since that is less than my 0.01 or 1%, there is enough evidence to suggest that, you know what, that is way too unlikely. It's a little bit more unlikely that that event happened, so we're going to reject the null. Here's an example. We are testing the claim that the mean pulse rates for men is more than 74. We've seen this example. We're going to write the null and alternative. Right, so we already actually did this in our last video. We're going to assume that the claim is true. We're going to assume that the population, in this case mean, is 74. And we're also going to test the claim that it's greater than. So the claim that we're testing is greater than versus that the mean is equal to 74. We found a statistic, or excuse me, a mean here, a sample statistic to be 78 with a standard deviation of 3.2. What I found here and what I want to test is the level of significance of 0.05. So our level of significance is 0.05. In this particular case, I'm telling you we calculated a p-value of 0.0001. So my p-value is equal to 0.00001. So essentially that is the probability that I got this sample of 78, assuming that the population was 74. So if the population mean was actually 74, the probability of me obtaining a sample mean of 78, given that assumption, is very, very, very low. So, you know what, since it's so unlikely, it is more unlikely, or it's more likely that this is not true, right? Because it's just way too low that I got this 78. So since our p-value, 0.0001, is less than our level of significance, I'm going to reject the null. I will reject HO, the null hypothesis, and I will say there's evidence to support the alternative. It's more likely that the mean is larger than 74. Because if it was equal to 74 and I got this result, this is just way too unlikely given this assumption. So, a good way to remember this: if the p-value is low, the null has got to go. So if the p-value is lower than the level of significance, the null has got to go. We reject the null. So if the p-value is the p-value is low, the null has got to go. Doesn't rhyme perfectly, but it helps some students.